All right, guys. So test tomorrow, right?
Right.
And I hope you're in a good place right now. But this is your last chance to ask questions. Generally, specifically, whatever, throw them at me. Once you get done asking, I might throw a couple things your way. But normally, you guys haven't gotten a taste of that because I'm always recording stuff and whatever. But normally on review day, people just walk in and start working on the review sheet. Occasionally, I get asked a question. So don't feel the need to focus up here. If you're like, I'm good, I'm just going to plug through my work. Yep.
If you do number traffic, it's like the one about scoring
This?
Yes.
Minus.
So remember, if x varies directly with y, then we have x over y equal x over y, right? And each of those is equal to some constant of proportionality. If f varies inversely, then we have x times y, x times y, right? If f varies jointly, then it will vary essentially directly with both these things. So if it's jointly, there would be two things that it varies with, and you'd say x over the y and the z. So the y and the z would both be multiplied together, but they would both essentially be directly related. But they would be jointly related in that regard. So the product is directly. Think like that. So x varies jointly with y and z is kind of like saying x varies directly with the product. So x directly with y and z. And that would be true x1, y1, z1, x2, y2, z2. Now, your problem here combines a couple of those things. It says x varies directly with y. So that inversely with y. So that tells you x times the y. But also, and jointly with w and z. So that means directly with the product of w and z. So divided by wz. So inversely with y, directly, jointly with wz.
So jointly is just put that excess on the.
Jointly means directly with the product.
If x and y were directly, where would the y and z still go on the bottom? So it would be x over y.
If it was directly and jointly,
yeah,
then I wouldn't have said that. I would have said it varies jointly with y, w, and z.
Oh, okay.
Because again, it's directly with the product. So if I wanted all of them in the denominator, I would say it varies jointly with y, w, z, and you put all three of them down. So I doubt you'd see that because it would be just a poor wording. But to answer your question, if it did say directly with y and jointly with w and z, you'd put all three in the bottom.
Okay.
I just don't think they word it that way, or I would word it that way. So, and remember, guys, on the test, I put stuff in there like the square of x. Well, that doesn't mean, what does that mean? The square of x. X squared. That's different from the square root of x, which would be the radical of x. So be careful about that kind of stuff. And then plug stuff in and use your slide rule, right? When x is 4 and y is 6, w is 8, z is 10, well then what is y when x is 10 and w is 12 and z is 4? So remember, what does the slide rule tell me?
Can you cancel out those 4s?
I cannot cancel those out because think about it. If I were to multiply both sides by a 4, they end up getting multiplied together. You can't cancel from numerators to denominators because they end up being together with each other.
So you can cancel denominators to denominators.
That's true because this ends up being over it. Or you can do a numerator and the denominator, obviously, of a fraction, right? But if it's on opposite sides, they end up getting crossed. So not cross, there's no cross canceling. It's like it's cross multiplication. So I'm going to slide this 4 up, slide that 12 up, slide that 10 down. That's my slide rule, right? That we talked about in here, which all it really is me multiplying both sides by a 12 and a 4, which cancels, and then dividing both sides by a 10, which cancels, and puts it over here. And at this point, I can just start canceling stuff. That's what I would do. Like I would cancel one of these 4s with that 8, leaves me a 2. And then I might cancel that remaining 2 right there with that 4, leaving me a 2. And then each of these 10s, I could cancel a 2 out of them, another 2 out of that. And at some point, I run out of stuff to cancel, but I still have a 12 and a 3, and a 5 and a 5. So y must be equal to 36 over 25.
Is it okay if I stopped canceling when I got to 144 over 100 because I know I could do that, and I put 1.44? Is that acceptable?
Yes.
Can you do cross multiplying?
Absolutely. If you cross multiply, the only thing I would comment on, like this is what would have happened. You have a 4, 6, 8, 10, 10y, 12, 4. If you cross multiply, you get that 12 and that 4 up there, and now you have an 8 and a 10 up here, and then you just have to turn around and divide again. So it's an extra step, but it's not the end of the world, right? If you want to stick with what you know, great. That little slide rule starts being really helpful with when you're doing proportions and other things. What else?
Can you do number 4 on checkup?
Yep.
But it says the square of y. I don't need to do the problem. Like, is the square of y, like, that's not root y?
Correct. The square of y is you're squaring it.
Okay.
Sorry?
It would say, that's the take we did last time. He said, was it for homework? We don't see.
Yes, for last night's homework. I believe, right?
Yes.
Yeah. Classwork, homework, whatever. We just didn't have time in class unless you were working on your own. What else?
This is a second question, like you don't have to solve it. So if it like gives you an annual, it says like in one of the roots is like 1 minus 2i, and so then you know the other one's a 1 plus 2i. Does it matter which one you start to synthetically divide?
No, why? Yeah, it'd be like saying, hey, I want you to start dividing numbers into 12. If I divide 2 first, I get 6. And I divide 3 second, I get 2. But if I divide 3 first, I get 4. And if I divide 2 second, I get 2. After dividing them both, you still end up the same thing. Now, in between that, it will look different. So like if you divide by the, whatever it was, 2 minus I first, what you get will look different than if you divided by 2 plus I first. But then once you divide the second one through, you'll still end up with the same thing. So no, in that regard, it doesn't matter which one you do first.
Also, are there any word problems with the inversely related?
It's possible. But I won't sneak something like the spring problem on there where it is a little tricky and you're kind of thinking outside the box, but unless it was that exact spring problem, maybe. But I'm not going to do anything like that. I don't typically do that. Typically, I figure I give you plenty of surprises during the week, and then on test day, you're just showing me what you know. Now, that's different when you get to calculus. When you get to calculus, man, you're punched in the face regularly on your test. It's that you just got to get used to it. But on the flip side, we do test corrections in there for points back. There's a lot of different things we do. And you can make a 62% on the AP test and make a 5.
Wow.
Yeah. You make a 70 out of a 108, which is roughly 62%-ish, and that's a 5.
So what percent you get to get like a 3, like constantly?
Not much. 40 typically out of a 108, which is a 30-something percent, 33, 34%.
How more is that?
But keep in mind, guys, passing is passing. So that means Alabama or Auburn would say, you made a 3, you would have passed our class. no use you taking again. That doesn't mean that's great. You can pass with a D, right? So a 3 is not anything like, we talk about, hey, you passed it. Awesome. Good job. You got a little college credit. But that being said, that's not awesome. I mean, 75% of my students make 4s and 5s. Some people make 3s. Occasionally, I'll have somebody fail, although it's not normal. Normally, it's 1. I mean, I always have somebody. I've never had a perfect one. But I've had many times where 33 out of 34 passed, 27 out of 28 passed.
We will be the perfect one.
Dude, I don't even know if I'll be here. We'll see. It's day to day, man.
Who could possibly replace you? Who could teach us about finance?
Thank you. But I don't know.
Yeah, who could do
Wait,
finance?
Wait, are you saying you're not gonna be here for like our senior year or next year?
I do not know.
No, Mr. Rory.
I do not know.
You have to be here next
Math
year.
team
I do
teacher
not know.
Jay.
No
Everything
promises.
better.
Next year at least. We'll buy you on a poke.
Here.
Once a week.
Oh my gosh, Mr.
Once a
Hey,
week.
here are 2 scenarios that could play out. One, I mean, I have 28 years in. You can retire at 25. So, and after this year, I really have an extra year of sick days because I have almost a full year of sick days saved up. Yeah, like I think I'm at 168 sick days. Okay, so I almost have 29 years. So I'm pretty close to that. Of doing, I mean, y'all make it fun. I mean, that's why I do it. I don't want to do an online school where I don't have relationships and can't have a conversation. But at some point, you're like, when you can retire and make 55% of your salary, which is not a phenomenal salary to start with, that's basically saying you're coming into work for 45% of your salary because you can stay at home and get the other part for free. Are you tracking with me?
No.
Like right now, you get paid X dollars an hour in public. Say it's 10, right? What if you are retirement age and they're like, hey, stay home. If you retire, we're going to give you your $6 an hour anyway. So what are you working for? The other 4. That's kind of how it is with me. I literally could say, hey, and this is something that I might do. I might be here for all the classes, but I might come in and if they contract me for 3. I don't know
Middle
him.
school?
Oh,
Hey.
retired. Yeah, he
But
just
they're
comes every now and then.
Well, there are people that are retired, or maybe Mr. Spence, they're retired, but they come in and they teach like first, second, third period. And they pay them that. Well, that, along with my retirement, was almost what I'm making now. So literally, I'm like, okay, I can teach 3 preps,
You could do it
stay here till 6 every night, or I could be done at 10:40 in the morning and go home with the same salary. It's hard to wrap your brain around that. But my hand might be forced because for me to teach 5 classes, I teach 6, and I've taught 6 forever. But this next year, there might not be, it's because it's a really weird dynamic in the junior class. There might not be 2 periods of calculus. And if there's not 2 periods of AP Cal, then I would teach 5. But to teach 5 instead of 6, now I would literally be coming in here to work for like 20 grand a year when I could stay home. I'm not coming in here 11 hours a day for 20 grand a year. That's insanity. You know what I mean? So my hand might kind of be forced because if I ever were to go to 5, and I've told them that, if you were to ever say you're only teaching 5, I'm out.
Oh, did they pay you extra for teaching a 6?
Sorry?
Did they pay you extra for teaching a 6?
They do. If you teach an extra 6, they give you an extra 20% a year.
How long have you been teaching 6?
4 or 5 years.
Yeah.
It takes so long to learn.
And that's another thing. You get paid on your retirement based on your highest 3 of your last 10. So if I were to ever go back to 5 a bunch, if I stay longer, I would have to, or I would be getting a significant drop.
Who would replace you?
Yeah, seriously.
Somebody, I don't
For
know.
real, who in the world?
Yeah, who could
That would not be my problem.
What did it take so
Thank
long?
you again. Thank you.
No,
Hey, what else you got?
no,
What else?
What did it take so long to like for a new teacher to learn like all the stuff that you learned and like?
My theory is that, honestly, my theory is that the math team would die.
If you leave.
My theory would be, because you're right, it took me 4 or 5 years to even get competitive.
You could get a.
Like to get competitive. It took forever. So either there, you would have to steal somebody from another place, and I would recommend a couple people. If I was completely out, You'd have to steal somebody who already does a really good job. But here's the thing. The people who do a really good job of it already probably have a pretty good setup, you know? I don't know that they want to start over in a new place. And there's not a whole lot of really good math team people out there. They've done it for so long. And longevity is key. So I don't know. I would think that they would just have pre-AP and they would just make it like pre-AP whatever. And then that's my theory. I may be totally wrong.
Saying they would just completely get rid
You
of
could
it?
do the
Is it gonna compete?
Well, I just don't know if anybody, I mean, if you told somebody, hey, you're doing this, they're going to do it. But I don't know if anybody really wants to do that.
Yeah, you have some good teachers too.
Guys, we gotta say math
That's like
team.
some of the
Yeah,
good reasons. I heard you and Helmer were such good teachers.
Well, but the big thing is we weren't great when we started. It took a long time doing that math team. I mean, a long time. It was like 3 or 4 years in before our kids were even remotely competitive because we didn't know anything. I mean, those tests are hard. I
So
mean,
the
you see.
Helmers take the, I was gonna say take the helm, but I didn't mean to. No pun intended, but could Mr. Helmers take the helm?
Oh, that, yeah.
By
Would you-
himself?
Again, Helmers knows geometry really well and calculus really well, but he would have to totally relearn all that math team algebra 2. I don't know that he wants to do that. I got to be totally honest with you. I don't know that he wants to keep doing math team geometry. If I were to leave, I think he would be super happy. If I were to walk out completely, he would be super happy grabbing my 2 APs, having his BC, and then teaching like regular cows. Maybe teaching 3 regular cows and be just Joe calculus. And that's all he did. I think he would love that. And then that would again would be a.
Who would teach geometry math team?
I don't know that they're doing it. I really do think that they would say, you know what, we're going to make it pre-AP,
This is scary.
period.
We should make a picture.
Can I pull the blinds out and send just this one?
Sure, don't pull it, just, yeah, a
Yeah,
little bit.
little thing.
What if you had a student teacher and like, they say recess for like all the school year so they can see what you did? And so then when like they're like, get their.
Well, if I were not here next year, they've missed about 7 months. So that would be a problem. But they could watch videos and stuff. I guess they could go back and
You could,
You have all
That would be
the
180 hours of video. Now you wouldn't have to learn all of algebra 2 because teachers around here know algebra 2. It's just the weird stuff. But it just takes time.
Discriminant of an ellipse.
You could start a little
Sure,
like
the
series
rectrices
on
of the.
YouTube. You could have a YouTube channel and you just.
But here's the thing: if I get out of education, I'm probably out. Like, there's a lot of things I wouldn't mind doing, or kind of think about doing, or
you could be like
you know.
a plumber, an electrician, or whatever you do with your yard.
And then you make.
Yeah, I should go into septic repair.
Mr. Murray.
It's your
Say again?
retirement
If
job.
you were to like just have like 3 classes and leave at like 10:40, they could be your math team classes.
Or you could teach whoever-
Well, and I don't know. Again, all those are up on the out there, so we'll see what happens.
If you taught
But
3,
see,
you
what
could
happens.
teach a
So
new
many great
teacher.
students through math
So
team.
we're all gonna
You never know.
I haven't left yet.
Is
I'm
this
right
gonna
here.
be
But
live?
thank you. And I will say that y'all have made me think differently about it.
Oh.
You really have. I mean, this has been a fun class. Y'all really gave me hope for a while because some of my other classes for a while, I mean, like 4th period started to come alive a little bit. I'm starting to have a fun. But like it was, y'all did give me when it was a dark fall. It really was. Until Thanksgiving, I came back from Thanksgiving, I really was renewed. But I was like, I don't know if I'm gonna make it past Christmas. I was done. It's hard. Y'all gave me hope. Thank you. Hey, what else? Got a test tomorrow.
Test tomorrow.
I just don't know for this synthetic division, for this one, why do you have to put it back over 2? Like, it's like.
Okay, so I think you're asking this, and I'll remind you. I'm going to remind you what you're doing, but you don't really have to know this. Okay, so hypothetically, if I asked you to divide, and my guess is this is not going to, I'm going to change these numbers in a second because it's probably not going to be nice. So mathematically, all you have to do, I'm going to show you how and then why. The how is set that equal to 0 and you get a half, right? And then you write down the numbers. 4, after that, okay, I'm going to change that 5 to a -6 right there. So it's both of them are -6. Half of that's 2, -4. Half of that's -2, -8. Half of that is -4, -3, right? And if it was a normal problem that didn't start with a number like 2 or 4 or 5, all you would do here is put the x squared, the x, the constant, and put that over 2x minus 1.
Yeah.
Right? So that's what you would do if it was normal. Now, why do you go and divide by 2? Well, the reason why is this is really this. So when I divide by that 1/2 synthetically, all I'm doing is taking care of that factor. I haven't, technically this whole fraction is still over a 2. So since it is still over the 2, I got to put it over the 2. Now, if you're wondering why that I didn't divide by 2 again, well, the 2x minus 1 is both of them, right?
Yeah.
So that's the why, but literally when I'm doing that, all I do, I don't think about any of that. I set this equal to 0 and solve, and I get that. I do synthetic division, and I go, okay, if there's a number out front, divide those constant and coefficients, whatever, by 2. But don't worry about that because it's already got it in there. You just divide those by 2 and clean it up. So that's kind of the why and the how. Yep.
What are we gonna do for Pi Day?
I don't know what they're going to allow us to do. So think worst case scenario, guys, get your mom to buy you a nice lunch and Chick-fil-A or whatever and sneak it in here and eat. That's a worst case scenario. Maybe we can bring in like a with a bunch of disinfecting wipes and you can, whatever. Do what?
Remember we just tried this together in groups?
You did what about video
Yeah,
games?
I learned all these sorts of video games.
Yeah, we can do that, but like we can't do a lot of that. I mean, I don't see us having big tables of community food to go in there and gobble up. And we're talking about a month from now, right? So
Individually packed.
I wouldn't expect a whole lot out of Pi Day.
So can we like buy like individual cookies and pass it out wearing gloves?
Like,
Again, those are things that might be options. If you wanted to like individually wrap them, seal them.
individual cookie
You know what else we
bags.
could do on that?
I don't know. Listen, at some point, somebody's Dr. Barnes is gonna have a conversation with this. Go, hey, this is what's allowed. But it's not gonna be fun like in the old days. Like my Pi Days are legendary.
No.
I passed the list. When you pass the list, there's commitment involved, And I mean, we'd have like waffle makers going, people making pancakes. I've had people cooking bacon on a griddle. Yeah, I mean, it's like there's so much food at the end. It's just unbelievable. Like I tell people, please come back and just clean this place out. I mean, just tables and tables. I would donate massive amounts. I know, but this year, I don't know.
Hey, there's a reason that you are forced to come back.
Yeah, that's
We
not.
can't experience
You
your
take
Pi Day.
Yeah.
Yeah, we'll see.
Please do the thing where you get paid the same.
The
Teach
hurry
3
Pi Day
classes
experience.
and we're one of your
We're
classes.
one of your
Just
classes.
pick
I know.
us.
As long as
Well, I mean, again, guys, I don't know. I have an open mind.
don't worry, we know you.
Yeah.
Wait, what if?
I mean, I've told my wife's like, do you want to do different stuff? And I was like, I do, but I'm still pretty young. I feel younger than I am. I'm 53, but I feel much younger than that.
You teach us and the
But I don't know. Like, I
others
still want to hike the Appalachian Trail. I mean, that's 6 months. I want to hike the PCT, which you got to do in July, August. Or maybe not the PCT, but the John Muir. I mean, there's a lot of different things that I want to do that would be great if I wasn't locked down.
Use your 168
You know?
sick days.
Well, I could, but that really puts you guys at a disadvantage.
Take a gap year.
Yeah, and that's a thought too. But if I took a gap year, here's the thing. Somebody is going to have to work incredibly hard to figure out the classes I'm teaching. They're not going to let them go. I wouldn't. If you told me I had to teach calculus 1 year and I taught calculus for a whole year, and they're like, because it was hard learning calculus again, so that my students didn't suffer that year, from the new teacher coming in, and then I come back like, hey, I'm ready to come back in. Okay, yeah, here's your regular algebra 2s. I don't know. I mean, there's a lot of things to consider, but I'm actually very financially solid. I've planned well. I've invested well. My wife's successful with what she does. I don't need to be a hero or anything like that. So there's quality of life. There's different things in the mix. Yes.
What if you chose the second option to have 3 classes today, and they brought, wait, no, this is actually a really good idea. And they brought in another teacher, so while you are like getting ready to leave, you can like teach them stuff. And so then you have less math team classes, and then it's just another person with a lot of energy. Like, if you're losing that energy, they have it.
Just get out.
I'm losing energy. I've actually got pretty good energy. I actually have
Your energy,
shockingly unlimited energy.
your energy being sapped by
My
another-
wife's like, you never get tired. I was like, I really don't. Like, I get itchy and I got to do something.
I don't get tired, I get itchy.
But anybody, what else? Test tomorrow.
Oh, okay, well, we have a question, because like, I know this is on like the thing, what's it called, the checkup, and it was like, if one value goes down, what's the other thing? Will there be something about joints? Because I know directly and inversely, will there be like, if 2 widgets are like jointly related and one value goes down, the other will go?
What
Or
is
will
it?
that be on the test?
Well, there's
We
no
have to
three.
know that.
It'd be the same as direct.
I don't remember a question like that, but like, but if I said X was jointly related to Y and Z, if this constant is, if Y goes up, for this to remain constant, what would have to happen to that?
It goes down.
Because these are technically what?
Inversely.
Inversely.
But then
So,
X would have to go up with Y.
but if you held Z constant and Y went up, then X would have to go up because they're directly. So that would be a really good question, although I don't have a memory of that on your test.
What is that? The value, it says here, it only has.
You told us in my last.
For the checkup. Oh yeah, no, you're right, Carson. That was going to be. It's not in the homework column. So yeah, you're right. I didn't. Yeah, I'm not taking it up anyway. But you're right. It was listed in the classwork column. Yes.
Will you go over the second way to get the remainder with X minus 1? Because like I know the synthetic division and the other way, like I don't know.
A second way to get the remainder with what?
Just plug it X minus. You just plug it in.
Yeah.
Is there a certain problem you're looking at?
And when you plug it
Yeah,
in,
but no, I didn't.
what you
I
get,
didn't know it.
what you get is the remainder.
Are you certain or are you kind of certain? There's a great commercial on Super Bowl. Y'all remember with Tracy?
That's why I bought.
He goes, "Are you what was the line?"
It was like, are you? I don't know, but it's like he jumped over the bridge in the car.
You know, I lost it when he goes.
He's like, oh, he's like, I think we can make it.
He said, "Do you think you can, or can you definitely?" You want to go? Y'all didn't see this?
No, yeah,
I
it's
was
not
at
like-
work.
They were the only 2 funny ones, really. There were
No,
2
one of
different
the
ones.
funniest one was like Alexa, the Alexa commercial, and it was just
Where was-
coming out
why
with
were
Cardi
you doing
B. No,
That's not
Cardi B.
Super Bowl.
Oh,
But it was one that was not.
Oh, with Wayne's World?
Yeah, that's what
I mean, it was
Wayne's
Super Bowl.
World.
They were downhill.
It was
They were so good, and now they're just like
Who's that?
like the Super Bowl commercial.
Yeah.
They used to be
Well, there's a.
They've
No, you're right. They used to be much funnier.
He's like,
But
they're really expensive now. Do what?
Yeah.
That's because we're obsessed with the
That was part of
community.
the, I think I can't.
They're like,
Yeah, whatever there were, there are 2 that I saw. I might have missed another one, but they were pretty funny.
Now it's just like, how many famous people can you get in one commercial?
yeah.
It's like,
Well, it used to be. I mean, they're $8 million a slot now, so most people are like, "With this kind of money, can we just be funny?" Where it used to be, for a couple $100,000, let's just have fun and whatever. But now it's like, holy moly, it's a lot of money on it for a 30-second slot. Do we really? Is it really helping us just to make a joke of it? Like I don't even remember what the company was advertising. It was so funny. I'm glad they did it because I laughed. But
Puppy Monkey Baby.
what?
I remember
Puppy Monkey Baby one. Remember that one?
I remember the
Maybe.
Yeah, it was like a puppy, a monkey.
Oh, yeah, the puppy.
Oh my
Yeah.
God.
I was just thinking about that. I was gonna say.
All right, what else, guys? I don't know why I'm recording this.
Wait, you.
I don't think I'm posting it.
Please give me a bloopers. You need a blooper
No.
excited.
Russell's gonna go watch it, trying to
It's
look
like
for like
the
the
inside
answer to
part
one
of
specific
Watson.
one. He's gonna have to skip through like 30 minutes. That's gonna be so funny.
Well, sometimes I don't even post the review day ones because it's just random thoughts. Anybody else, guys? Anything? If you don't, I have a couple I want to mention.
Oh, 15,
On.
review.
Guys, if Mr. Hurley leaves, drop out of math team. Just drop out.
I will. If we
Y'all,
leave,
I
okay.
can't start that. Y'all, my manager just emailed me.
Oh my God, what did they say?
Well, there's not a graph on
They send
15,
me my
there's a graph on
username
the
and
review.
password to like.
15 on the review or the checkup?
On the review, yeah, on the review.
Sorry.
Okay, guys, this is a great question for you. And I could have made it where you really needed the graph. Like on this particular one, if you saw the graph and you went, oh, what's that? And then you went over here to solve, you would have said factors of the -3 over factors of the 1, and you would have started dividing the 1 in, and then the -1, and then the 3, and then the -3, and you would have found that these two work, but that's only 2 of the roots, and how many do you need to find? You need to find 5 total, but you need to find 3 to shrink it down, right? But at this point, you would have gone, well, these didn't work. Maybe one of these was a double root. So then you would go back and try 1 again, and it wouldn't have worked. But then you would have tried -1 a second time, and it would have worked. And you were like, ah, there we go. And it wouldn't have been the end of the world, right? Because you only would have failed once, twice, and the second time around 3 times. So you still would have been fine. You would have probably spent an extra 1.5 or 2 minutes on it. But this tells you what? Roots are where the graph is equal to 0, where the y values are 0. This is like y equals. So the roots of that are 1. And what happened? Because it crossed at 1. But if it bounces at -1, what is that telling me? A double root. So that tells me that 1 and -1 and -1 are going to work. So I'm giving you 3 roots. Now, you still have to find the last 2. And to find the last 2, you're still going to have to do what with this polynomial? Shrink it down to an x squared. So you still got to do the math, but at least I didn't have to go and check all those other values. Now, here's the thing. What if that wasn't a 3? What if it was 30?
You could use Descartes' rule.
Maybe, but I don't know if it's going to help you. But look at the possible rational roots. 1, 2, 3, 5, 6, 10, 15, 30. So if you'd have started doing this, yeah, still maybe you find the 1 and the -1. But then you got to check through all the rest of those before you go, oh, wait a minute, maybe it's a double root. Your life would have been miserable, but not if you had the picture. Because if you have the picture, you immediately know if it crosses at 1, it's a root. If it bounces, it's a double root. I've got all 3. So it's a huge help, this picture is. Are y'all seeing that? Now, so I didn't even need to do possible rational roots for this. I was given them that are going to work. So all I got to do is shrink it down. And that shouldn't take me much time, although I do still have to do it.
You got this.
Man, I did that the other class too. You're right. 5, 4, 3.
It's the most common mistake besides copying them. Oh,
Yeah.
that is copying.
You're right. All right. So 1, 4, 4, 8, 8,
Look at the
8,
speed.
8, 3, 3, 0.
Damn.
Then
Next.
1, -1, 3, -3, 5, -5, 3, -3, 0. 1, -1, 2, -2, 3, -3, 0. So now I'm at a place where I can do what?
X squared.
I can use the quadratic formula. And that may look like it. Hey, every year I have somebody who gets down to here on a problem like this. And they go, oh yeah, that factors. X plus 3, X minus 1.
No.
And they go -3, 1. Now, other than factoring wrong, why is that not right?
Because
3 times
You
-1
can't have
is
more
not
than
3.
2.
That says 1 is a double root. It's not.
This would say that 1 is a double root, which means there should bounce there. It doesn't. It also says -3 is a root,
But it's
which
not.
means it would cross there.
But
It
it's
doesn't.
not.
So there's all kinds of reasons why that doesn't make
Has
sense.
to be imaginary.
But again, are the last 2 most likely going to be integers?
No.
No, you're going to be forced to use the quadratic formula there on these anyway. So go ahead and just get in the habit of doing that to find those last 2. But man, if I give you a graph, use it. And then when you get to calculus, don't ever assume from a graph that that's a 1 and a -1. Because it could be 0.9926 and -1.017.
Move.
But you would have a calculator and you could graph it and find those roots. And you'll learn how to do that next year really early. really early. You may already know now, but you would learn that really quick. By the way, it wouldn't hurt you guys to go and buy a TI Inspire 2. If you do buy a TI Inspire 2, do not buy the one that says CAS. Don't do that. There's a TI
A lot of numbers.
Inspire 2, but there's also a TI Inspire 2 CAS.
No.
The CAS is awesome. It's a computer algebra system. And the computer algebra system means I can type this in and set it equal to 0 and say solve, and it will solve and give me all the answers. It makes it effortless if it says CAS. I can say factor, and it will factor it for me. It does all this stuff. I liken our calculator to being an extension of your brain. No, the CAS is just your brain. It gives you way too much. Do you have a CAS?
I don't know.
Does it say CAS up at the top right corner? Okay, then you don't. You have the right one then.
Oh.
So if it says TI Inspire 2, that's what y'all's is? TI Inspire, yeah, CX2, sorry. If it says TI Inspire CX2, that's the one you want. Actually, a TI Inspire CX is fine, but not the CAS. They're not cheap, probably 140 something bucks on Amazon, but you're gonna need one. You can get away with the TI 84, but if you have a TI 84, don't plan on taking BC Cal because he teaches from the Inspire.
What about the CX1?
I have all, well, they're not ones, they're just CXs.
Oh, okay.
That's what,
It's under the paper.
that's what this is. This is a TI Inspire CX. The only real difference is that's made a little, just a tiny bit user-friendly, but it's hardly noticeable. A couple of the menus have changed a couple things,
I was looking at.
but I don't even have the new one. I have these because these went on sale for like, they were clearing them all out, selling them for like 50 bucks a pop, and I was like, I'll buy a few of those. School money. It's like, no, I sold them to all my students. I couldn't do it personally, but I got.
Sold them to your students?
No, they would not let me buy them and give them to my students at the same price. They would not let me with school money, but they would let Coach Bagley buy them for the school store, which I don't even know if that's operational. Is that still up and running?
No.
It used to be. Yeah, there used to be a school store, but they would let him buy it for the school store and sell them to you at a small profit. So I was thinking, I was buying them for 55 and selling them to y'all for 60, or he was selling for 60. But I would collect the money, hand it to Bagley. It's just dumb.
Unnecessary.
Yeah.
So the sum product rule is x squared, and then the opposite of the sum, x, and then the product.
Yes, it's x squared minus the sum, whatever that is, times x, plus whatever the product is.
Okay.
And if you should ever forget it, just check it. Look, if those were fact roots, then these would be the factors. And if I FOIL them, I would get this. Well, what did I just do? I added it, changed the sign, and I multiplied.
And then on the one where it says, like, if f is this big thing, and then f at 7, and like, you could never really plug it in, what do you do there? Do you set that as a divider?
Because our remainder theorem says that finding f of 7 by plugging it in can also be found by dividing it in and using just the remainder. So you have now 2 ways to evaluate a function and also 2 ways to find a remainder. What else you got?
I'm confident in this test.
Good.
I did not have a single idea what was going on like 2 days ago. But
Yeah, I was so confused, but then yesterday
I
when we
think
went
I'm on
through like
track
all
now.
of it, I was like,
I think I'm on track now.
Sometimes you just
I
need
keep
to
that
start the
about-
review and
Yeah, I
then like,
just sat and did the review and I was like, all right, cool.
Say it once.
Yes, right.
Can you write like a positive, negative, imaginary? Can you write it like it's like in parentheses, comments, or do you have to do it?
You can if you want.
Okay.
That helps you organize stuff.
Yeah.
I restricted rules.
I mentioned this problem a couple days ago. Let's see if you remember something about it. Ignore.
We're gonna remember all of it, don't worry.
Good.
100%.
Makes it easier to grade when you make 100.
Yeah.
You get home a lot earlier.
Zoomed in 2040. 400.
All right, check it out.
Except make it up. Is x gonna equal 14?
How can we use?
Sorry.
Why would it X equal 14?
I mean, it's not gonna be. It's probably gonna be good.
All right, check it out. So hopefully your brain's doing something like this. Oh, f of 2, just plug in a 2. What?
Oh, you can.
Not going to get anywhere plugging a 2 in immediate, my first thought, right? Then you go, oh, wait, there's that thing about I can also use the remainder. So I can synthetically divide. So you go to synthetically divide with the 2 and you go, oh, that's a lot of zeros. And then you think, wait a minute, that's a red flag on both of these. Now, at that point, you got two options. You could do the remainder theorem. I'm sorry, you could do synthetic division, but keep in mind, I'm not plugging a 1 just like a -1, so that it's going to do more than change signs. You're going to have some crazy multiplying and adding and subtracting going on. Not going to be pleasant, okay? But if you look closely, like if you just remember this, should something like this happen, you think, okay, what if I were to plug a 2 in? Isn't that really a 7 times a 2 times a 2 to the 120? And isn't that a 7 times an 8, which is 2 cubed, times 2 to the 118? And isn't that really 2 to the 121 when I multiply together?
Yes.
And that's 2 to the 121 when I multiply together.
Oh, and that's
So I literally have 7 times 2 to the 120. Negative 20 times that.
Yeah.
And this gives me 80 times that, right? But isn't that really -5 times 4, which is 2 squared times 2 to the 68? And isn't that 5 times 16, which is 2 to the 4th times 2 to the 66, and that's 2 to the 70th, right? So isn't that really -5 times 2 to the 70th, +5 times 2 to the 70th?
So for like, divide by how much you divide by 20 and 80, kind of get.
Well, no, I'm just trying to rewrite these in a factored form to see if they happen to be opposites. It's kind of like my last hope before I have to just get busy, right? I'm certainly not plugging 2 in there and go to the 120th. I'm not going to do that. But I could still do synthetic division with 121 spaces. But before I do that, I'm going to try this as a last resort. Now, at this point, I think I'm home free. Because what is 2 to the 10? Come on, I should hear crickets on that.
24.
24.
And this is -3 times 2 squared, right? So at that point, I think I'm okay. -5,120 minus 12 plus 5. What's that? -5,127? Okay, I'm good. Right?
Right.
So, but again, that would be like if the remainder theorem, factor theorem, whatever, if that doesn't work for you, just remember that it might be something else that's curious like this. And literally all I do is just factor it all out so I can see what I really have there. Factor that all down. And once I see it all down, I'm like, oh, wait a minute, that's the same factors, but they're just opposite signs. They cancel. And I've seen that in little math tournaments. It's usually a ciphering question. And of course, people are like, I mean, I would love to have like a little drone flying over these kids writing all the zeros out. I can do this. Or literally, 2 to the 120. Okay, 2 times 2 is 4, 8, 16. Hopefully not, but
If I try to do the 30 seconds.
all right, what about this? I only have 4 minutes, so what if I gave you this? And I told you 4 minus I is a root.
Or plus I.
How do you know that?
Because they're integral
All the coefficients are real.
Because if I have integral coefficients, which actually the rule is if they're real, but you're right, integers are real. If they're real coefficients and constants, then imaginary numbers always occur in conjugate pairs.
So if the rule is, it's if they're rational, if you have a root 2 or a root 2.
Right. If this is an irrational number, they would have to be rational to be in pairs. If it's an imaginary, they would have to be reals to be in pairs.
So wait, rational, like, is that just any?
But as long as
Irrational, it's not an I, but it had like a radical that's left over, like 4 minus root 3, 4 plus root 3.
So it can just be any number, if it's rational is like any number that's like 1, 2, 3, 4, 5, 6.
rational-
I'm not 100% sure what you're saying. What I'm saying is that would lead you to that if these numbers were rational, just like this leads you to this if each of these numbers are real.
As long as
But
they're
what's the
integers.
difference between real and
As long
rational?
as they're integers.
Rationals are numbers that decimals go forever, but there's no imaginary part. So it's rational. This is a number that actually 2 plus about 1.7 is about 4.71, blah, blah, blah. It's some value. It's on the number line.
Wait,
We can tangibly talk about it. An imaginary number is like, what the heck is that? It's part of mathematics, but it doesn't graph on a real number.
so like, if you said like 2 plus root 3 is a root, like having 1, -9, 23, -1, like that, you could still like have both, right?
Yes, if I told you that was a root, this would also be a root because these numbers are rational numbers.
But how do this go on forever? Because it's like 0.000 back?
What?
Well, because if
That
you
means
have
these would
zero-
cross on the number line. The graph would cross, not at perfectly at 2, but at some decimal value. It's irrational. It's on the number line, but it's just an irrational number.
So if we see what it is.
This is not crossing on a number line. These are imaginary numbers. The real number line is the x-axis. That's like the real part. The imaginary part's out there in space. So these, you would not be able to look. I can't look at that and go, oh, that's what the graph looks like. I don't get that. All I know is that these didn't cross. Right? My question was this, before we went crazy here. How are you going to solve this thing?
You can either
Synthetic
multiply
division.
together,
Now, what do you mean multiply them together? Because they're not factors.
or you have to make them into factors.
I could make them into factors and multiply them together and do long division, or I could use the sum and product rule to bring them together and then use long division, or synthetically dividing, which is usually the best bet because you get instant feedback on whether you've done it right each time.
First one's nasty. and the
First one's
second-
nasty, second one not so nasty. Is it ever a good idea to look at this and go, I'm just going to check possible rational roots?
No.
Guess what? If you were to do that here, you actually would have gotten them. Because the
Yes!
but not on your test.
No!
But yeah, on this one, actually 2 and -1 did work, so you could have gotten with it, but you won't on a test.
So you could have just like, you usually get away with.
I'm just saying, on your test, if you go, I'm not going to divide those, that's so much trouble. I'm going to start checking roots, and there's not many to check, so I'm just going to check those. You're not going to get anywhere on your test because I've created the problem so that they're not those. They're 2 more imaginary things.
But we can always kind of anticipate that a 4 minus root I or something like that, like an imaginary would have a conjugate pair.
If those numbers are real.
Yeah. So if there's no other I's or negatives or anything, yeah.
If you weren't okay,
It's either
They're a high chance, they're like a triple.
I don't know if I have one. I have to go back and look. I have put a couple trick comments for bonus questions, but not on the regular test. I don't see anything being real tricky.
She said she's excited, like, looking for her, having you start next. You know how like.
Yeah. To figure out like if you need
Yeah.
It is.
I gotta get it.